Hi everybody, and welcome to McCardle Math Academy. In this little video we are going to do a slightly more complicated example in which we use the method of integration by substitution. Okay, so our example here is going to be to find the indefinite integral of e raised to the square root of x divided by the square root of x. So when we look at this integral, and we know we're going to try to apply the method of substitution, you think about what we could set our w equal to. So we always want to find an inner function of some sort that we set w equal to. So a pretty obvious choice in this case is going to be the square root of x. So that's what we're going to try first. Again, occasionally you might choose the wrong function for w, and you'll notice that after the first step of algebra. So in our case here, we're going to set w equal to the square root of x, and it's very helpful to rewrite this from radical form to exponential form, so we have x to the 1/2. The next step is then to take a derivative of w with respect to x, so you get 1/2 x to the minus 1/2, alright, which if we rearrange this is 1 divided by 2 square root of x. Okay, and then as we know, the final step here is to solve this little mini equation here. We have dw dx is equal to 1 over 2 square root of x. We solve that for dx, and rearranging that you'll see that dx is 2 square root of x dw. Alright, so in this little box here is where we did our work leading up to the substitution that we're going to make. And the important characteristics to remember is what we set w to be and what we found dx to be in that case. All right, and if you think through, if you think through the logic here from our original integral, you'll notice that we're probably going to be able to cancel that square root of x that appears in the denominator. So let's see how this work is going to end up. We come down here to the main integral again, and we're going to make our substitution. So we originally set square root of x to be w, so we're now going to have e raised to the w. You might be tempted to also replace the denominator by w, but you'll quickly find that that doesn't really get you anywhere. So let's leave the square root of x in the denominator for now. With experience, you'll be able to know when to do this and when not to do that. And finally, you'll replace dx by what we found for dx, which was 2 square root of x dw. And you'll notice it'll make you happy that we can cancel those square root of x's. So we're left with the integral of 2 e to the w dw. Everything is in terms of w here, and it fits a very basic integral formula for e to the w. And we all know that the integral of e to the w with respect to w is e to the w again, and we have our integration constant plus c. Alright, and the final step is to sub back in what we set w to be. W was the square root of x, so we plug that back in where we originally saw w here in the final equation. And this would be our final answer for the integral of e to the square root of x divided by the square root of x. Alright? And a nice final step is always to check your answer. And how do we check? Well, we know that this answer that we found down here, is an antiderivative of the function that we started with up here. So therefore, if we take a derivative of this down here, we should end up with precisely what we started with. So let's do that. We're going to take a derivative with respect to x of 2 e to the root x plus c. We know that this is a basic chain rule from Calculus 1. So this is 2 e to the square root of x times the derivative of the square root of x, which is 1/2, x to the minus 1/2, and then obviously the derivative of c is 0. So rearranging all of this, you see that the 2's cancel, and we see that we're left with e to the root x over the square root of x, which is exactly what we started with. So this check is just the final step to make sure we got the correct answer. Everything checks out the way it should. Alright, so again, this was a basic example of integration by substitution. Check back for more videos. See you then.